Hi guys, welcome back to my channel. So in today's video, we will talk about normalization in databases. But before we practically get into the whole process of normalization, let's first talk about what exactly is normalization and why do we do normalization. We'll further talk about anomalies as well as dependencies and determinants and in databases. So starting off with normalization. What exactly is normalization? So if you have worked with relational databases before, you know that a relational database is a database that has a relationship with itself as well as other tables. So you can think of normalization as breaking up a huge database or a huge data set into multiple new tables that are related to each other. And you will see exactly why this is the case when we start doing the whole process of normalization. So why do we do normalization? Why is normalization important in databases? Well, the main reason why we do normalization is because we want to improve data integrity. We also want to minimize data redundancy as well as repetitions of attributes. And we also want to avoid anomalies. But before we move on to talking about anomalies, please note the emphasis on minimize. And this is because sometimes we deliberately repeat data to make our relational databases work. For example, if you think about foreign keys are attributes that are referenced in other tables but have been referenced in a different table as a primary key. And we do this because we want to make our relational databases work. And this is actually called controlled redundancies because we do this on purpose. So now let's talk about anomalies. So what exactly is an anomaly? So you can think of an anomaly as when something is not exactly where it's supposed to be, or something that's inconsistent with something else. And most of the time anomalies happen because your database is not normalized. So it's sort of like an opposite of normalization. So when your database is not normalized, it leads to or it results in an anomaly. And there are three different kinds of anomalies. So we have an insert anomaly, we have an update anomaly, as well as a deletion anomaly. And to better explain those, I think we should look at the next table. So let's first look at an update anomaly, and I'm gonna use this table as an example. So an update anomaly is when duplicated attributes are updated but not all of them. For example, imagine we have this spreadsheet and it's a long spreadsheet with thousands and thousands of records. And you actually want to update your course code here, C003. So for example, let's say math changes its course code to C004. If you change it here, it's not going to automatically change in Mary's record. You will need to individually update each and every record, and obviously that becomes very tedious and a very long process, and you will take a very long time to update everything, especially if you have thousands of records. So that is what you call an update anomaly, when duplicated values are not updated but not all of them. And then moving on to an insertion anomaly, we're still going to use the same table because it's just easier to explain. So assume you have this long list of database with thousands and thousands of records. So an insertion anomaly is when attributes cannot be inserted into the database without inserting other attributes. So for example, if this is the only database that you have and you want to insert another course code here, let's say for example it's C005 and it's a geography course, you cannot just insert a course code C005 and it's named geography without actually inserting everything else here, without having a student ID, a student name, and a supervisor for that course, as well as a student or rather supervisor name, as well as a student mark. So that's what you call an insertion anomaly, when attribute values cannot be inserted into a database without inserting other attributes. And then last but not least, we'll talk about a deletion anomaly, and this is like the flip side of an insertion anomaly. And this is when certain attributes are lost due to deleting other attribute values. For example, if you want to delete course code C001, for example, you can't just delete it here in this cell only. You'll need to delete the entire row, and that leads to a deletion anomaly, and that's not something that you want in a database. You don't want to leave your database with null values on purpose. So now let's talk about dependencies. And dependencies are very important, especially when you start practically doing or when you start normalizing your database, both dependencies as well as determinants. So you can think of a dependency as a constraint that determines the relationship between attributes in your table, and we'll see why shortly when we start doing our normalization. And dependencies are dependent on determinants in order for them to be uniquely identified. To say this properly, a determinant, which most of the time, if not all, is usually a primary key, determines other attributes in a table. And those attributes that the determinant is trying to determine are called dependencies, because dependencies are dependent on a determinant, if that makes sense. And there are three kinds of dependencies. So we have a proper functional dependency, we have a partial dependency, as well as a transitive dependency. A proper functional dependency is when all dependent attributes are dependent on the entire primary key or entire composite primary key. And when we do normalization, we should always aim for proper functional dependencies. And then we have our partial dependency, which is when a dependent attribute is only dependent on only a part of a composite primary key. So if you have two attributes that make up a primary key, then your partial dependency is when a dependent attribute is only dependent on one of those attributes instead of both of them. And this is not something that we aim for in normalization. And then last but not least, we have our transitive dependency, which is when a dependent attribute is not dependent on any part of a primary key or any part of a composite primary key. And that brings us to the end of our small tutorial, or our small get to know normalization video. In the next video, I will be showing you how to normalize your databases, and we will use both first normal form, second normal form, as well as third normal form to normalize our databases. But for now, that's it for this video, and I will see you guys in the next video.